most of the stuff tonight, I'm guessing.
Yeah.
It's much easier to verbalize algebra than it is geometry. Geometry, you have to pretty much send me stuff, but most of algebra is not so much graphical in nature. So let me open up my sketch pad here. Go ahead, I'll try to write down whatever you want to verbalize.
Okay, and I think we're gonna split this session into two 30-minute halves because my sister has a bunch of problems and she's in a different spot than me.
Okay, just if you can, kind of keep track of that. I'm not actually observing a clock in my mode, so let me know when the half hour comes around.
Yeah.
What's your sister's name?
Jessica.
That's what I thought. I was going to guess that. I seem to remember a Jessica being a sister. So, okay. So what do you got tonight?
So 12 parentheses 6 plus 2 over 4 minus
End parentheses or not?
No.
Okay.
Minus x minus 1 over 3.
Like that?
Yeah.
Now end parentheses?
Yes.
Okay. And is it an equation or just this expression?
It's just the expression.
They want you to simplify it.
Yes.
Okay. It's the first thing we should do.
So we should get common denominators so we can subtract the two.
Well, we don't really need a common denominator because this 12 is a common multiplier of both denominators. But we can do something really simple, and then we have 8 over 4. Let's go ahead and reduce that to 2. Can't usually do it the way I just did it, but in this case, 8 over 4 is 2, correct?
Mm-hmm.
Okay, now distribute it.
So it'd be 24 minus 12x minus 12.
Okay, first of all, realize that that entire thing is going to be subtracted. So you should put it in parentheses. Okay? Second of all, that 12 over that 3 is equal to what?
4.
And that goes in front of the parentheses. And then what goes inside the parentheses is that. And the reason it's so important to use parentheses is notice this thing is going to come out to be plus 4. If I did not have parentheses there, it would come out to be minus 4. Now, finish distributing it.
So it'd be 24 minus 4x minus 4.
Oh, minus 4 times minus 1 is?
Oh, positive 4.
That's why the parentheses were needed. Absolutely. Take away those parentheses and you do get a minus 4. But with the parentheses, you don't.
Okay.
Whenever you see subtraction and you see a rather complicated term, put parentheses around what is being subtracted. Because x minus 1 over 3 is what is being subtracted. Okay? And, okay, what do you got else?
Then we have parentheses 6 minus 3 end parentheses. Parentheses 3 over x minus 3 plus 9 end parentheses.
Like that?
Yes.
Okay.
Oh, the first one's in x. Instead of 6 minus 3, it's x minus 3.
Okay. Hold on. Okay. What am I going to do here? I got a couple of choices, actually. You can think of the first thing in the parentheses as being a binomial, correct?
Yeah.
You could also think of the second thing as being a binomial.
Mm-hmm.
And I could FOIL these. In other words, I could go this times that times that times that, and that times that. But there's actually, because there's two x minus 3's in this thing, I don't think foiling it is the fastest way. I think distributing it is. And distribute that to both terms. What do you get?
You get 3 parentheses x minus 3 over x minus 3 squared.
No, in other words, what we're going to do is we're going to take this binomial and we're going to multiply it by that. What do you get?
3.
Okay. And now we're going to take that same binomial and multiply it by 9. What do you get?
157.
Well, no, you're multiplying 9 times x minus 3. What do you get?
Oh, you get 9x minus 27.
Okay, simplify that whole thing.
So it'd be 9x minus 24.
There you go. That's your answer. Now, notice that if we treat that x minus 3 as a single term instead of a binomial term, it allows us to do that. And in this case, it's the most efficient way to get that problem done because I have this x minus 3 involved. Make that an x minus 2, and then I'm going to go ahead and do it the way I suggested first, FOIL it. In other words, treat it as two binomials that you got to FOIL. But as long as I got a denominator of x minus 3, I'm going to treat that x minus 3 as a single entity and distribute it to both terms.
Mm-hmm.
Okay? All right.
So the next problem is like, it's a bunch of vocabulary that she never went over because we had a test.
Okay.
So it says an equation in the form ax plus b equals 0. A cannot equal 0. And such as 3x plus 17 equals 0 is called a blank equation in one variable.
Linear x. A linear equation is of the form like that. That's what you're looking at there, is something that is in mx plus b form.
Okay.
Okay? That makes it a linear equation. A linear equation means straight line. It's not a curved line. It's a straight line.
Mm-hmm. Okay.
It's a variable in x because that's the only variable that's in that expression or equation is x. But if I had to graph this thing, I'm starting at 17. I've got a slope of about 3, positive 3. There's the graph of it.
Mm-hmm.
And setting it equal to 0 will give you that point right there on the x-axis. Because when this whole equation is equal to 0, it means you're talking about the x-intercept of it.
Okay, so the 0 would be the y.
Yes.
Okay.
The equation of that line is the following. The zeros of that line, and what that means is you set y equal to 0. The 0 would come at minus 17/3. That point right there is minus 17/3.
Okay.
Okay. Not sure, are they asking anything else about this? I think I covered all of it.
Yeah, that's all it goes over.
Okay.
And then for number 2, it says 2 or more equations that have the same solution set are called what?
2 or more equations that have the same solution set. For instance, here's one equation. The solution is x equal 1.
Mm-hmm.
Another equation, I'm just going to multiply everything by 2. Has the same solution, x equal 1.
Mm-hmm.
So 2 equations that have the same solution set. Those equations are identical.
Yeah, I was going to say equal, but that's not the word they're looking for.
Here's the thing. If you graph one of them, let's see, one of those equations, that equation was, the first one was that is y equal 2x minus 2. Okay.
Mm-hmm.
Second equation was 4x minus 4. Well, it's not the same equation. Notice that they have different zeros. Notice the second equation. Oh, they have the same zeros. So the example I gave you is not correct. They're not identical. That line is that equation. That line is that equation.
Mm-hmm.
They happen to have the same zeros. In other words, if I set that equal to 0 and that equal to 0, I get the same answer. The zeros occur when x equals 1. So read your question again. I might have misinterpreted it.
2 or more equations that have the same solution set are called what equations?
Well, the 2 equations that I mentioned do have the same solution set.
Mm-hmm.
I do not know what the answer is. Do you have answers to these?
I do not.
You don't know. Terminology is a thing that is an area that I do not consider that important in math. Because you go to different countries, you get all kinds of different terminology, but the math is the same. Okay? Math is math is math. Terminology is what we happen to call it in this country. So I'm not sure that's even a part of math. I'm not sure what they're looking for here in terms of the terminology.
Okay.
I'm trying to think of something else. 2 solutions that have the same solution set are I would say two equations that have the same zeros, but I don't even know if that's correct. That's not it looks like they're looking for a single word.
Yeah.
I don't know what it is they're looking for. Let's go
on. So number 3 says the first step in solving 7 plus 3 parentheses x minus 2 end parenthesis equals 2x plus 10, no parentheses.
Okay, what is the first step?
Would you distribute first?
Yes. I like to think that the first step in solving almost all equations is get rid of denominators and parentheses.
But couldn't this have more than one answer? Because you can start like subtracting the 7 from the
Let's first of all get rid of those parentheses. Rewrite it. Go ahead.
7 plus 3x minus 6 equals 2x plus 10.
Now, in one step, bring all your variables to one side and all your numbers to the other.
So it would be
Which side did you bring your variables to?
I brought my variables to the left side.
Good. That leaves the coefficient positive. That's what you want.
Yeah.
That leaves 1x.
Okay, so I got x equals 9.
Good. It's only one solution, not multiple.
Mm-hmm.
Now, I could come up with another equation that x was equal to 9. I don't know what those two equations would be called in terms of a single word. So I still can't figure out that previous question.
Yeah.
She
never went over it.
What's that?
She never went over it. We had a test today, and she said that this should be.
Yeah, then I don't know. I mean, you could look in your book if you have a book. And look on that page. Maybe there's a bunch of words. You could give me a multiple choice. I could probably guess which one it was. But barring that, I don't know what they're looking for.
Yeah.
I'm going to close this page out and start again because my drawing tablet is acting funky. Let's see if this solves it. I'm going to have to unplug it. No, I think that solves it. Go ahead. Next.
So number 4 says the fractions in the equation x over 4 equals 2 plus x minus 3 over 3.
Like that?
And then it keeps going to say can be eliminated by multiplying both sides by
what?
Well,
that is, okay, here's an equation that, what do we got? We got denominators. Remember our goal, eliminate denominators and parentheses. We don't have any parentheses, but we got denominators. Can we eliminate both denominators in one step?
We could make them equal.
No, we can't make them equal. One is 4, one is 3. However, we can find a least common multiple that gets rid of both of them. What would that be?
12.
Okay, so I'm going to multiply the whole left side of the equation by 12, and I'm going to multiply the whole right side of the equation by 12. Now, what's the left side become?
So that would be 12x.
Don't do it that way. Always, always, always reduce numerators and denominators before you do anything else.
So it'd be 1/4 x?
Not 1/4. Take that 12. What's 12 over 4? That's the first step. What is 12 over 4?
That would be 3.
Okay, so you immediately in one step eliminate it to 3x. And I don't mean by saying 12x over 4. I mean doing 12 over 4 first. You understand the difference?
Not really.
Well, we'll get to it on the right side of the equation. Distribute that 12. What do you get?
On the left side?
No, we've done the left side. We're left with 3x.
Yeah, right.
How about the right side?
So it would be 24 plus...
Again, do not multiply the 12 times the x minus 3. Take the 12 over to 3 and simplify that.
So it would be 4.
And you need to add those parentheses. Because that 4 multiplies the entire numerator.
Okay.
Okay? In other words, I could have said the alternative, which would be 12x minus 36 all over 3, right?
Mm-hmm.
That was the other way to do it. But then this is, I'm going to divide top and bottom by 3, and so I end up with 4x minus 12. So that's what that's going to turn into, is 4x minus 12. The advantage in simplifying the numerator and denominator first is that it makes you work with smaller numbers. The way I did it, I got directly to that. I never had to work with a number as big as 36.
Okay.
And that's always going to be the case. If you take your numerator, especially if it's evenly divisible, and in this case we know it's going to be, because that's what led us to the 12 in the first place. We knew that it was a multiple of 3, also a multiple of 4. So we knew that 12 divided by 3 was going to simplify to a whole number.
Mm-hmm.
And then the key is to take that 12 over the 3, turn it into a 4, and multiply that 4 by the whole numerator like that. Okay, so what's in the next line here?
3x equals 24 plus 4x minus 12.
Now which side are you going to take your variables to?
We're going to take it to the right side.
Yeah, and what goes on the left side?
A 1 or 0?
Combine your numbers first.
24 minus or plus 1x minus 12.
Well, here, let's do this in 2 steps. In fact, let's do it in 3 steps. Sometimes you can make a simple mistake by trying to do everything in 1 step, okay? So what happens when we do 24 minus 12?
24 minus 12?
Mm-hmm.
Oh, that's 12.
What's that?
12.
Okay. See what I did?
Mm-hmm.
Okay. Now move 3x over to the right, so you have x plus 12 equals 0. See why?
Because you got rid of the 3x.
Well, I subtracted 3x from both sides. And 3x minus 3x is 0 on the left side, and 4x minus 3x is just x on the right side. But I still have my number on the right, so I got to move that to the left. So what's my final solution?
It would be 12 equals x.
Nope. I got 0 equals
Negative.
x plus 12.
And
You're solving for x. Isolate that. Get rid of anything that's with that.
so negative 12 equals x.
Yep. That's it. Remember, get rid of denominators and parentheses. Most of the time. Every now and then you'll get a problem where you don't want to get rid of the parentheses. For instance, like this. If I'm going to solve this problem, I do not want to get rid of the parentheses. That turns that thing on the left into a quadratic. Makes it harder. The easiest first step here is to take the square root of both sides. And if I take the square root of the left side and the right side, I get x minus 3 equals plus or minus 4. So x equals plus or minus 4 plus 3. So x equals 7 or minus 1. Okay, so this example that I just showed you here is one of the few cases where you do not get rid of parentheses first. You take the square root of both sides first. So maybe the rule should be, no, you don't even want to say get rid of exponents, because that can often mean multiplying that thing out. In other words, the first step could have been, if I was looking at this, to multiply that on the left out. Do x minus 3 times x minus 3. And unfortunately, you'd get a quadratic like that, and that just makes it harder to solve. So the easiest way to solve that is to take the square root of both sides. So that's one of the exceptions to my denominators and parentheses. But usually if you stick with that rule, you can't go wrong most of the time.
Okay.
All right. It's, we got time for maybe one more before Jessica comes on?
Yeah, it's another word problem.
Okay.
So we reject any proposed solution of a rational equation that causes a denominator to equal 0, right?
Yep.
Okay.
Oh, that was a fill in the blank?
Yes.
Okay, and the blank was 0?
Yes.
Okay. Yeah, you can't divide by 0. This right here is equal to what?
That equals nothing.
Undefined. It actually has a word, undefined. Another way is it's almost equal to infinity. Not quite, but that's a new topic for another day. But the whole point is you cannot divide by 0. And this, we don't even know what that is. That's not only undefined, that's indeterminable. Okay? So the thing to bring, in other words, you can have 0 in the numerator. That's equal to 0. That's okay. You just cannot have 0 in the denominator, ever. All right. Is Jessica right there?
I can go get her. She's like in the room over.
Okay.
Okay, she's coming.
Okay. What math is she taking?
She's in the same one,
Okay.
but her class is in a different spot.
Okay. Well, you guys can probably both benefit from watching a recording of this, because you get the recording of your session and her session, which, you know, you might have some different problems that you can do.
Yeah.
All right.
Hey, Jessica,
Yes.
we've worked together before, haven't we? I seem to remember doing a session with you.
Yes.
Okay. Wow, my dogs just came in. That solves an experiment I've been wanting to do for years. No, they used to come in when I was finished with a session. And I thought they were, how do they know I'm done with a session?
I don't know.
And I thought, well, maybe it's because I scooped my chair out and moved to another table, and they're hearing that and acting kind of subconsciously. Well, guess what? They just came in when I ended the session with Joseph and started it with you. So I didn't do anything different. I didn't even stop talking. And they still knew that my session ended.
It's weird.
It is weird. How did they know? So anyway, so you're taking Algebra 2 trig also?
Yes.
Okay. What kind of problems do you have tonight?
Okay. I have no idea what they're called.
Okay. Well, if you can verbalize them, we'll write them down and we'll try to solve them.
Okay. So let's start with square root.
Okay.
1 over 64.
1 over 64?
Yes, with the 6.
Equals
Like,
6?
No, not equals 6. It has a 6 right next to the square root sign.
Like that?
No, it's like almost like a cubed root, but instead of the 3, it's a 6.
Ah, it's this. I get you. That means the 6th root.
6th root, okay.
Yeah, which means what number multiplied by itself 6 times. Now, let's talk about this. When you see this, that actually means square root. The 2 is implied. Okay? If I see this, that means cube root. Well, notice that cube root is what number multiplied by itself 3 times equals 8. Well, that would be 2.
Mm-hmm.
And if they're asking questions like that, 2 is usually involved. Turns out that 2 to the 6th power is 64.
64.
So what is the 6th root of 1 over 64?
1/2.
Yes. Very good.
Okay.
Now, it's not quite complete. Actually, it is. Sorry. Let me change the thing for a moment and say this. That would appear to be the same problem, but it's not. It's not the same problem. This means x equals plus or minus 1/2. Because when I take the 6th root of both sides, I get x. But when I take the 6th root of that, whenever you're taking an even root of a number, your answer always needs to begin with plus or minus.
Okay.
But it's a subtle distinction here. In other words, if I say the square root of 4, that absolutely means positive 2.
Yes.
If I want negative 2, then I'm going to say the negative square root of 4. There's negative 2. That notwithstanding, if I say x squared equals 4, x is equal to plus or minus 2. That is a true statement all day long, so are both of these. And basically what it means is that when you see a radical sign without a sign in front of it, we are to assume the sign is plus.
Okay.
So this is definitely plus 2 only. But when I am solving an equation where I have to take the square root or the 6th root of both sides, my answer is always plus or minus. If I'm taking the 3rd root, my answer is either plus, or if I'm taking the 3rd root of a negative number, like the 3rd root of negative 8, that's actually negative 2. Not plus or minus 2, but negative 2.
Okay.
So in this problem you gave me, I think the answer is 1/2, not plus or minus 1/2.
Okay.
All right, what else you got?
Okay. Cubed root of x to the 4th.
S?
X.
X?
Yes.
Okay. The easiest way to look at this is it's the cube root of x cubed times the cube root of x to the 1. See how why I factor x to the 4th that way? In other words, there's a principle involved called this. And it's true whether you have square roots, cube roots, 4th roots, 6th roots, doesn't matter. So I can always take that left side of the equation and factor it into the cube root of x cubed times the cube root of x to the 1st. You see how it factors that way?
Uh-huh.
Now what's the cube root of x to the cubed?
X.
So this is what you're left with. X times the cube root of x.
Okay.
Make sure when you write this, because that can very easily be misread as x cubed. You don't want that. So let's take and stick that 3 in there. Or else separate it enough so that there is no misunderstanding. Like that.
Okay.
Okay, what else?
64x to the 6th. Wait, 5th root, 64. X to the 5th.
5th root
Yes.
of 64x to the 5th?
6th.
Okay. Again, we want to think factoring. Something goes there. Something goes there. What can we put in the first circle so that it comes out to be a nice whole number and variable?
One of them's gonna be x. Can
Now,
I do 64?
we know x to the 5th must be part of it, right?
And then the other side's x to the 1st.
Right. What numbers? How do we separate 64?
64 is the 6th root of 2. Could I do it that way?
Yeah, but we're looking for the 5th root of a number. I tell you what's really useful in math is to know your powers of 2.
Yeah.
They just come up so often that remember them. That's 4, 8, 16, 32, 64. So there's the magic number.
So,
What's the 5th root of 32?
2.
Aha. So we want a 32 to go in there. If a 32 goes with that, what has to go with the x?
2.
Okay. Now, what's that equal to?
32x.
Not 32. What's the 5th root of 32?
2.
So that's equal to 2x.
2x.
Times the 5th root of 2x.
2x.
There's your answer.
Okay.
What else?
5th root of 2x.
That's the problem?
Yeah.
That's the answer.
Really?
Can't simplify it. I could rewrite it. Oh, maybe they're looking for you to rewrite it a different way. That is also the same as that.
I think that's what they're looking for.
Okay?
Okay.
But these are not, they're not really equal. They're just a different way of writing the same thing. But it is useful to know that when you take the square root of x, that's the same as x to what exponent?
1/2.
Okay? And if I take the cube root of x,
x to the 1/3.
How about if I take the cube root of x squared?
Then x to the 2/3.
You got it. Okay, what else?
Fifth root of negative 1/32.
Could I take an even root of a negative number?
Yes.
Can you take the square root of negative 1/16?
No.
No, you can't take the square root or the even root of negative numbers, but you can take the odd root. In other words, I could take the third root of negative 1/8. What would that be?
Negative 1/2.
Yeah, not plus or minus, just negative. Only negative 1/2 times itself 3 times gives you negative 1/8. So what is this answer?
Negative 1/2.
Correct.
Okay.
All these where you have these big numbers like 32 and 64, they're almost always going to give you whole numbers as answers. And that's why it's really useful to know your powers of 2. It's because you immediately recognize that 32 is 2 to the 5th, and 64 is 2 to the 6th.
Yep.
Okay, what else?
Fourth root of 162 x to the 5th.
162?
Yep.
X to the 5th, okay.
Yes.
So what we're looking to do is factor this thing inside the radical sign so that part of it is x to the 4th, and the other part is some number whose 4th root is a whole number. So what do you think that might be? And we're going to factor it into two things that are both 4th root.
And then one's going to have x to the 4th, and then one's just x.
Correct. Now, 162 is not a perfect exponential factor of anything. So cut that in half.
81.
Is that a perfect 4th of anything?
No.
Yeah, it is. Just think
Yeah,
they're
3.
small numbers.
Yeah, 3.
3, exactly. So I'm going to leave 81 there, and I'm going to put 2 there. Now, what is the answer to that?
3x.
Okay. And the rest of it is simply...
4th root 2x.
Yeah. Can't really simplify that. I could put it as 2x to the 1/4 power. So actually I can simplify that a little bit. Let's just talk about that for a second. Your teacher may actually want this as an answer. I can rewrite it. No, that's not. Which I can then at least combine the x's. But it's not a very pretty answer. It's 3 times the 4th root of 2 times x to the 5/4 power. So that would also be an answer, but I'm not sure it's a better answer. In fact, it looks worse to me. I would say the proper answer is going to be that right there.
Yeah, I think that's what she's looking for.
It's the same thing as down here. Just know that you can always manipulate these things. In other words, if you have same base, you can add exponents. So I realize we have an exponent. X is a common base. You can add the exponents to get 5/4.
Yeah.
But then the 2 is also being taken to the 1/4 power. So that means you can't really combine those two numbers very nicely. Otherwise, I might do it. You know, if this was the 4th root of 16, then that's 2. 2 times 3 is 6, and a nice pretty 6x to the 5/4 power. So it just kind of depends on what your answers look like as to whether you should change the expression or not.
Okay. So, how about negative y to the cubed root of 81x?
Negative 1 to the what?
It's negative y.
Negative y?
1y, but yeah. To the cubed root
Of?
81x.
Like that? No, surely not.
No, it's multiplied by, so it's negative y. Right next to the cubed root.
Okay.
Yeah, like that.
Okay. So, what does 81 need to break down to that we can do that? In other words, first of all, let me rewrite it. Whoops, excuse me. Whereas all I'm doing is separating the variables.
It's right next. Okay.
Now, what can we do with cube root of 81? Can you simplify that? That's just a number, but we want to give it as an exact number. So what can we factor 81 into?
Wouldn't it just be 3?
3 times what?
27.
Okay. So the cube root of 81 becomes the cube root of 3 times the cube root of 27. We still have the cube root of x over here. Now we can do something with the cube root of 27. What's that?
3.
So I'm going to put that there, and it's positive 3 only. Minus sign in front of the y doesn't go anywhere. Got cube root of 3. I got to put that in there. And the cube root of x. And then finally y. Well, notice that that line is the same as this line.
Just rewritten.
It's rewritten. I reordered it a little bit, and I took the cube root of 27. However, now I can put these two back together again because they're both cube root. So let's write this a little bit better. Let's put the y in front because it works better when you leave the radical sign towards the end. But I can combine that 3x back together again. That's a much more attractive answer.
Okay.
Part of the problem with putting the y last is that it frequently gets left like that, and then you don't know if the y is under the radical sign or not. So from a safety perspective, you put it in front. Although you can notice right away that I could misread that also to be y cubed. I don't want that, so I'm going to put that 3 right there so I can't misread it.
Okay, that makes sense.
Okay.
Alrighty. That's about all the problems that I have.
You know what I'm impressed with is the difference between you and your brother's stuff. This was a lot different. I don't remember any problems at all that he had that were like this. Maybe there were 1 or 2. But that's good. You should each review the other's session because you'd probably find them both helpful. Or both of you would find them helpful.
Interesting.
I'll give you one.
Okay.
Always do the root first on problems like this. Notice what happens if you do the numerator first. You get what? 64, the cube root of 64, right? Okay, that's a big number, 64. What if you do the cube root of 8 first? What's the cube root of 8?
2.
2 squared? Never had to deal with a number greater than 8.
Okay.
Give you another one. Notice that if we squared this first, we got a big giant number. I don't even know what it is. But if we take the cube root first,
It was just 3. And then square it, which is 9.
9. So always do the root first when you have a fractional exponent. And most of the time they give you problems like this, that the denominator root of that number is always a small whole number. It's either 2, 3, or 4. And I mean that. It's not ever 5, 6, or 7. It's 2, 3, or 4. So just know those numbers, what the cube root of 8 is, or the 4th root of 16, things like that.
All right.
Anything else, Jessica, at all?
Not that I can think of.
Okay. Well, I can let you go. I don't want to just hold you because it's not quite 7 o'clock, but
It's perfect.
yeah, if you don't have anything to cover, I'll let you go a little early. You get to go? You don't have any last questions?
I don't think so.
Okay. Well, nice talking to you again, and I'll talk to you next time.
Perfect. Thank you.
Bye-bye.